So we have a set of low-level schemas, which I think of as encoding facts. Right? Our system maintains atomic facts about it. One of the facts is there can be an author, and an author is a string of up to 50 characters. So you're going to notice some things about this schema. First, some stuff at the top. We're using always qualified elements and unqualified attributes. Doesn't go either way on that. Actually, the qualified elements are really important. Anything odd about this from what most people's perspective? Anonymous types. All of our schemas use anonymous types, period. We never use a name type. What we're saying is, what this really says is, if you encountered author from this namespace, this is what would have to be in it. And that's all it says. And the beauty of that is, this assertion is freestanding. I can encounter this without any knowledge of the context in which it appears, and I can know what it is. And I can know whether it follows the rules. As soon as I start mixing in type hierarchies, that just goes out the window. It gets really wacky really fast. So all of the facts that we assert in these low-level schemas are individual elements, always of anonymous simple type. If I have two of these that happen to need the same content model, then I have another anonymous type that by coincidence has the same content model. Okay? Now, these facts map into our database. Someone asked about a point I made on a slide. They asked this in the question QA last night. They said, how can you say that our schemas take precedence over the database schema? Right? My answer last night was that's because in our system, XML files at the beginning of the process are the real source of truth. Right? People are publishing documents into our system, and the actual originals are stored in a document management system. The fact that we shred some stuff into a database for queries and to push it out into the web is really a side effect. That's an implementation technique. The source of truth is the document management system. And that's what lets me say, I mean, if our database fell over tomorrow and we had to rebuild it the next day, it'd be okay. I'm in no way asserting that that's true in your business, right? So, take whatever approach you want. But in our system, the schemas, if we want to make a change to our system, we start by going and altering one of those facts. And then that propagates out through the system. Does that make sense? Now, what do we do with those facts? We assemble them into larger things. So all this file contains is these single elements about a certain piece of information. We then assemble these together into broader constructs, and we tend to pull them together using groups and group references. There's the base group. It's all the things that from the base namespace, the facts from the base namespace, the facts from the published namespace, etc. Now, this particular schema is designed to ensure that any manifest that comes into our system has the minimal amount of stuff to be correct. Because at the entry to our system, we want you to put in a manifest for technical article, SDK documentation, seminar, whatever. We just need to say, does it meet the minimum requirement to come in here? So we say, look, you got to have this stuff, which is necessary to identify the piece of content, and you got to tell us what the content is. But after that, it's all wildcards. Right? So this schema says, look, to get in the door, you got to have that minimal stuff, and then you can have stuff from these namespaces, but otherwise that's it. Does that make sense? Now here's where things get kind of funky. At some point, we have to branch in our plumbing and assert that you have passed in a technical article, and so I have to verify more than just stuff came from these namespaces. So let's go look at a schema for that. This one looks and feels exactly like that one. The difference is it actually specifies all the stuff that may or may not occur. Some of it says must not occur. Right? So we say, look, that first schema was enough to get you in the door. Later on in our system, we're going to say, you said this was a technical article, now here are the requirements. Does that make sense? Now here's the part that takes getting used to. check out the target namespace. Right? Now let me go back to the other one. Check out the target namespace. Both these schemas define things in the same namespace. And they overlap perfectly. And that's intentional. And the reason it's done that way is because of how schema works. If we put this in a different target namespace, we'd have to change the namespace affiliation of all the elements when we went to process it with the schema, which means we have a lot of transformation costs to basically switch from one namespace to another just to do the validation. So we got to the point where we said, well, you know what? What we're really doing is saying at one point in our system, the door's wide open. So we expect you to send in a manifest, and we expect it to look like this. At another part of our system, we're saying the door is not wide open. If you have said it's a technical article, even though the XML instance looks exactly the same, and that's the point, nothing changes in the instance document. Further down in our plumbing, we say, at this point, we have more things to assert. Same target namespace, different schema. And the way we actually do it is the more specialized one actually has an ID called technical article, and I wrote a schema loader that looks for a marker in the target namespace and whacks off the back and knows to pick up the one with the right ID. So at a given point in a system, you can say, I wanted schema A for this namespace as opposed to schema B. Right? And the beauty of this is throughout our system, at any point we want to, we can assert whatever it is we feel the need to assert. And this is one extra benefit of this schema model. In addition to only using anonymous types, we only use global elements. So if you look at one of these, note that these are all element ref. We never use local element decals, ever. That does two things. One, it means that every element you encounter, being a global element decal, can be the root of a validation tree. So any element you encounter, you can validate, no matter whether it's one of the big complex ones or one of the individual little ones. It also, again, is part of guaranteeing that you always know what you're looking at. Let me show you a kind of freaky schema to really drive that point home. Where did I put it? This schema right here plays some games with namespace qualification. So it has a global element called foo, and the semantics are of foo means this. Down here, I have a type or an element called bar, which is a sequence of a local element called foo, also an integer, whose semantics are that, as opposed to this. But then a reference to that one. That means an instance of the bar type will have two foos inside it. But one of them is a local element foo, and it's qualified, so it has the namespace prefix. The other is a global element foo, and their semantics are different. And as a guy just programming against this XML document, I can't tell. The only way I could figure out when one was the local foo and when one was the global foo, I could do it by sequence, but hey, if I change this to a repeating choice, you're screwed, right? Or I'm screwed, depending how I look at it. The problem is, the only way I could tell these two apart is to dig through the schema object model as I processed it to figure out what part of the schema I was talking about, and that's crazy. I am not going to write code that does that. By only using global element decals, this never comes up. Right? So my new approach to schema, it's really easy. Always anonymous types, always global element decals. You know what turns out to be really hard when you do that? Generating C# code. But here's the thing. The code that you are going to get, going back to the conversation yesterday about type systems and compatibility, the code that you're going to get generating off schema is not the code you want inside your system anyway. So in almost every case, you've got one internal object model. You're going to do work to turn it into another object model that you're going to then have a serializer turn into XML. Why not just go right from your object model to XML? You have to write a layer of mapping code anyway. Why not map it all the way to the XML at the other end and avoid that intermediate step? Right? So at this point in my life, I could care less that I can't generate C# classes from this. You know what the class behind this actually looks like? It holds a DOM. It exposes the navigator interface so you can read and transform. And then it has type-safe functions that you call to modify it, which I believe is a real sweet spot. Right? We have this problem where we tend to look at the world as at one end of the spectrum there's the DOM, and at the other end is my objects with no XML traces left. There's so many interesting possibilities in the middle. The biggest problem with the DOM, aside from some efficiency things, is the code to update it. Writing into the DOM sucks. But if you have a class that says I expose the navigator so you can read this thing, that's easy. And then I've got some properties so you can modify it, or some functions so you can modify it. That's a pretty reasonable model. The other thing I've been thinking a lot about lately is, given the constraints, I got to get that off the screen. That's the bad one I keep pointing to. Don't do that. That's scary. Because of the constraints in these schemas, because we only use anonymous types, and because we only use element ref, I actually believe, I haven't had a chance to really go do this. I've experimented with it a little. But I believe, given those constraints, you could actually generate a set of classes. You could write a tool that took schemas that match this pattern, that generate a set of classes that would do two critical things. First, they would implement XPath Navigator on top of your objects. Implementing that, I actually have code that does that. It's not that hard, right? Especially when the thing's this stylized. The other thing they would do is implement code that validated the incoming document using XML Reader, because it's like 4 times faster than XML schema. So once I got to this model and said, this is how I want to look at the world of XML, starting to build tools that gave me a type-safe wrapper and were really efficient actually looks pretty easy, because I could care less about round trip. Right? I've given up on the walk up to any schema, walk up onto any object model, and make it work right. So personally, I found that by taking schema and going back towards XML, right? To me, this is what XML was about. I could look at an attribute or an element and know what it is without having to do all this gunk around me or any of the rest of it, right? And looking at schema as it's just a way to declaratively say, the XML you gave me has got to look like this. Right? That's where I want to live. And that's what I want the tooling to support. Question?
Is one side effect of this that within one namespace, each element has namespace?
Yes, because having 2 elements, like I did with that foo example, in the same namespace from different semantics is pure evil. Because no XML programmer on the planet is going to make it work right. Because they're going to run an XPath expression that says whack whack prefix colon foo, and they're going to get both of them, and they're not going to understand that there's a difference. And the fact that schema lets you do that, okay, fine. You know, somebody somewhere. The problem ultimately that I have with schema is the notion is you've got to know where you are all the time. And the way people program XML, you don't. You don't know where you are all the time. Nobody writes code like that. And it turns out with some of the trickier stuff to just be excruciatingly painful to do. And I would just stay away from it. The one thing you do lose here, because it's element ref, you can't do things like the one I really want to do in here is I really wish that I could fix this content type to have the value technical article, but the fixed attribute can't be applied when you use element ref. So the one piece that isn't in here yet is I actually believe that on a global element decal, or wherever else it would fit in, what you really want to do to express things like that is to embed XPath across your content model. You could do it using the schematron bits. You could do it with your own thing. It's not such a big deal. And the benefit of that is not only can you deal with like fixed, you can deal with co-occurrence constraints. Right? The infamous, you can have this attribute but not that element. Those things that you can't say in schema. So actually, so that's the last part of my schema model. Now, what does this mean for a web service? That was the last thing that someone asked last night was, if I have a web service, how do I use this? And if we live in a world where there's no single normative schema, what do I do? Right? My answer is when I develop my schema or my service, I will give you a schema. It's going to look like this. And here's the thing. You can alter it if you want to. If I've got a wildcard and you want to replace it with something else, go ahead. If you want to change my occurrence constraints, if you want to get rid of some stuff and say, I don't care if those things are there, I really just want a title and then anything else that occurs, I could care less. Knock yourself out. That's the key. I'll give you a schema that I believe says, here's what I'm going to deliver to you. But in giving you that, you don't necessarily have to take that and say, that's what I care to receive. With RSS, which is extensible, maybe you say, my RSS stuff only works with a certain mod in place. So I'm going to take, well, there is no schema for RSS. There are some proposed ones, but if there was one, right, you could say, I'm going to take that, but I'm going to take that wildcard, I'm going to say, right here, there's got to be this mod that I need. Right? That's fine, because it's about declaring what you want. And right now, we're trying to do both things. We're trying to say, I wrote the schema that tells you what I will provide, and by definition, that's what you want. And I question that assertion. I think that leads to very, very brittle systems. Simon.
Sure, quickly, this looks really fantastic. You know, it's one of the best XSLT schema work I've seen. It looks a lot like relaxing.
Uh-huh.
You know?
And so the question is, why am I not using that?
Microsoft.
Dude, that's so stereotypical. The fact is, I actually went and played around with some relax NG bits. There were really two compelling reasons. In the environment that my team was ready to work in, the tool support for doing schema work and the support in the framework was better. If someone said, here's an equivalent relax NG implementation in .NET that just plugs into your stuff, I would definitely consider it. But for us, it was really, what are our developers used to? What do they want to work with? So it was easier to say, we'll use schema, but in this very constrained way. That was a lot easier than we're just not going to use it. That would have been a much harder battle to fight. But look, if someone wants to use schema, if you want to use schematron alone, think of these technologies as someone gave me XML, and my job is to say, does it have what I want? Do it with XML Reader, do it with a DOM, do it with XPath, do it with schematron, relax NG, do it with regular expressions. It doesn't matter, right? You just need some way to say, did I get what I expected? And the key is, what I want and what you send, those requirements may vary. You don't want to tie those things together. It must be time to go. Thanks.
Thank you very much, Tim Ewald.